Okay, so um, I've given a similar talk to this before, so I'm sorry if you've seen some of the parts in this. It's a little different. Hopefully it doesn't bore you for an hour if you've heard me talk about HTML5 games before. Um, okay, Blaine already went over this stuff. I'm the other founder of iStev, along with Blaine. There's Blaine. Here's our Twitter handles. Anyways, these slides are up on GitHub. There's a little bit of code examples in here. Also, there's a lot of JavaScript in this, so if you put yourself as a beginner in JavaScript, don't worry. I'm not going to spend too much time on the actual detail of the code, but we'll be sure that there's at least one advanced JavaScript person on each team, like Blaine mentioned. Okay, so what are we here for? We're here for making web-based games, right? What are web-based games? Games in a browser, right? For the last 10 years, what has that meant? That's meant plugins, right? So plugins suck. Plugins are like Applets, Flash, Silverlight, Unity. Sometimes they work on Linux, sometimes they work on your operating system, whatever, junk, right? So that was the last decade. So what happened now? Where are we at? We're in HTML5. Well, what does that mean? HTML5 is just HTML. It's just new stuff for us to use. It's an evolving standard. So some people might be wondering, are we able to just use this if it's an evolving standard? It's not finished. It's finished in the way that English is finished, right? Like we can go ahead and use it right now. There's some problems, and things are changing, but we can go ahead and just jump in and start using it. So before I get into any actual details of what HTML5 stuff we want to do, is there anybody here that's done any type of game development at all? Okay, so the concepts are the same if we're doing an HTML5 game or if we're doing an Xbox 360 game or whatever. The same type of functionality we're going to be using no matter what our platform is. But what we're going to do is either write a game engine, use a game engine. Basically, just the guts of what our game is, our backbone of our game is a few concepts. All games need to be able to render and animate things, right? We got to move stuff around on the screen. There may be some type of physics involved, 3D physics, 2D physics, things moving around on the screen. It's got to handle input, keyboard, mouse, a joystick, whatever. The game engine itself should be helping us manage our resources, want to pull in images. This is especially important on web-based things because web-based things typically aren't installed already. We don't just download a big executable, right? We have to pull in resources dynamically. Because of that, we need some type of resource management. You might want some AI in your game for single player. We might want to do some networking in the game if we want a multiplayer game. Audio, we need to produce sounds, or the game's kind of boring without making some sounds. We also might want some user interface things, a way to help you out doing menus for your game, things like that. So that's just sort of typically what is in what's in a game. So with HTML5, these new standards, there are a lot of HTML5 games, engines sort of popping up now. I've got a big list of them over here you can get to. I'm particularly fond of Frozen.js, and that's one that myself and Blaine have put together. But we're not dictating what technology to use, just HTML5. Like, don't go build a Flash game or you're going to not get a tablet. All right, so HTML5, that's the parameters of this. Okay, so HTML5, what is it? What do we get? What's the big deal? To me, the biggest, most important one was the ability to draw on a canvas. Now, we've been able to put pixels on the screen before. This isn't anything new, but how are we doing it before? We were having a Flash object or VML or SVG, or we were doing different things to try to just draw. Well, now it's just native to the web. We have this canvas object, and it lets us put a pixel anywhere on the screen. So if we can put a pixel arbitrarily on the screen in an open standard way, we can build anything, right? If you could put a particular colored pixel somewhere on the screen, programmatically, you could do whatever. Now, there's a whole lot of performance. There's how big of a code base do you have, all kinds of things like that. But we have the ability to draw, which is the first thing that we need. Okay, let me get to a little bit of code here. This is a canvas object. This is sort of where it starts. So HTML5, right, it's just HTML. We get some new tags. This new tag canvas, we just define it just like that. We can give it an ID so we can reference it later with our JavaScript. We can set height and width to it. This is pretty important though. The height and width of the canvas are like the coordinate system of your canvas. So if you say 150 by 300, that's actually the pixels. If you style it though using CSS, and that's not your coordinate system. That might make it bigger on the screen, but that's not. So it's a big distinction in your canvas. If you want to, just keep this part simple and have a coordinate system that you're able to work in and you know where things are at, set the height and width to the thing. We could do it programmatically. We can get our canvas object. We can set some attributes on that canvas object. Question in the back? It is, and you know what? Let me see if I can. Maybe I could zoom in a little. You know what? I will. Why don't I do that right now? Oh, great. That's the local one. Sorry. We just put this up on GitHub, and I didn't have that loaded. Can you grab Lane? He's back there, right? I'm not sure where you put this at. I don't have the GitHub loaded, the URL. Okay. Let me see if I can just zoom in for now. Is that better? A little better? More? Let me see. Hopefully it doesn't kind of screw the rest of the slides up. Got me. How's that? Better? Viewable? You guys in the back, can you see the text? Okay, cool. So, like I was saying, we get a canvas object. We can set height and width on the thing programmatically. We can do it in the tag. It's all pretty much typical HTML type things. Okay, great. So you've got this canvas, but you want to draw on the canvas. Now, to draw on the canvas, we need a drawing context. What that is an API in JavaScript to allow us to do these things, to draw. So when we have our canvas, we can ask for a drawing context in JavaScript. That context could be 2D or 3D. 2D, right? Just 2D shapes, rectangles, circles, things like that. If you ask for a 3D context, that's going to give you a context of Webgl. In good browsers, anyways, you'll get a Webgl context, and I'll get more into that. But let's just start with 2D. 2D is a lot simpler. We can do things with that context like set the fill style, which is when we draw shapes. You got? Yeah, slides are up on Hack Phoenix Twitter. Okay, on the Hack Phoenix Twitter. Good. Okay, so let's see. So the fill style is like the colors that we want to put in our shapes that we're drawing. Fill, in this example here, fill rect means to fill a rectangle in that context. Using that coordinate system that I mentioned earlier, in this case, 0, 0, that's the upper left. In most graphics programming, right, the Y positive goes down. So the top left is your origin, your 0, 0. And then we're just drawing 0, 0, 450 to 450, a height and width of a width of 450, a height of 450. Stroke style is when we're drawing shapes, what we want the border to be, the edge. Line width is how thick we want that border. And stroke rect means just draw a rectangle filled. It's the same as fill rect, except it's not. It's still drawing a rectangle, but it's not filled. So stroke just means do the outside. Okay, that's all boring. And let's see here. I'm going to. Oh, that's wonderful. You know what? Why don't I grab the real slides from here? Okay. So that was boring, right? We just drew a rectangle. That's not a game, but we're using the API. We're starting to draw a little bit. Okay. We're not going to have a game without some images, some bitmaps, something that we're editing outside of just drawing the pixels, right? We want to use GIMP or Photoshop or something to build some content for this game. So we've had these APIs in JavaScript for a long time. We can create a new image object. one thing though with creating an image object programmatically in JavaScript is that doesn't happen synchronously, right? We say we create an image object, we give it a source, but that's an asynchronous request, so we don't know when that's going to finish. If it's a big image, it might take a while. Meanwhile, the page is still doing stuff, so we have to give a callback. We have to say when our image is done loading, go do something. So in this case, when the image is loaded, we're going to take that same context and we're going to draw. And this is small again, isn't it? Okay. So we've got an image. We're setting its source. When it loads, it's going to draw. And you can imagine, pretty simple, right? Draw, and wow, we have a picture on the screen. That's still not a game, right? Like, we've been able to put pictures on the screen for a long time. That's actually rendering in a canvas, so it's not like I can save image as, because it's not an image, it's a canvas with some rendering in it. But still a long ways off of building a game. Okay, so why is that? Why is it that we can't just draw? Because a game runs in a loop. This loop we want to run 60 times a second, so that we can have a refresh rate on the screen of 60 times a second. Anytime we don't run it 60 times a second, the users will notice. So if your game is choppy, it might be because you're not doing the 60 times a second. And what are we doing 60 times a second? We're going through a bunch of things. We're in this loop. We want to check for user input, handle anything like if a rocket hits a spaceship, handle that. Do all this collision detection. Do all of these things in the game to update the state of the game. Drawing and playing sounds, we know are going to happen after the update. That particular order doesn't matter as much as we want to draw and play sounds after we've done all of our updating the game state, and just keep running through this thing. So here's a real simple programmatic example of making one of these loops. So we check the time, so we'll know how much time has passed. Maybe handle some input, update our game state based on the amount of time that's passed, and then draw. So pretty basic, but it's important to note that we are really considering how much time has passed in each one of these loops, because it's not always going to be the same. It might be 16 milliseconds, ideally, right? 16 milliseconds times 60, or if we run 60 times a second, we'll get about 16 milliseconds. Anyways, since this is not exact what these numbers are, we need to be able to handle that. So we need to know this much time has passed. Maybe our character's just a little ways off. More time has passed. He should be a little further. That way to the user, even if things do slow down, our characters on a screen have moved the appropriate amount of distance. So don't get hung up on this right now, but something we'll have to refer back to is that we're running these things in a loop, and the timing is really important. Okay, this is a little bit more complex, and don't, like I said, the slides are up, and don't think you have to remember all of this stuff right now, because the gaming engines that I mentioned earlier kind of make this stuff a little easier. So that loop that I showed, that was just a function, right? Run this loop, but we want to run it 60 times a second. Recently with HTML5, we have gotten another API called Requestanimationframe. Requestanimationframe says it does some cool stuff for us. It tries to go 60 times a second. Also, if you're off on another tab, that doesn't keep running, because you probably don't want the game state updating when somebody's off doing something else. We could just use kind of old school JavaScript set timeouts, but that always runs, no matter whether the tab is showing or the browser's minimized or anything like that. And this right here is a shim, basically. This is a newer API, so not all the browsers do it. I think for this hackathon, you're probably going to want to target Chrome, test on Firefox as well, maybe IE, and this little shim right here lets us grab a request animation frame using the new API. If not, it falls back to the old set timeout way of doing it. Okay, great. So we have this request animation frame API. We want to give that to our game loop, run it recursively, and that's all that example is doing there. But like I said, don't get hung up on that right now. And so here's a really cheesy example, but what that's doing is running the game loop to make something move kind of fluidly across the screen. If I were to just run a loop without any timing, if I just said, run paint to the screen this many times, it would probably just display in 1 second or less than a second, and that it would have just painted all at once. You wouldn't have seen an animation because we need this interval. Okay. Also, I mentioned input management. Again, this is going to be handled depending on what you're using. If you're using just native JavaScript, handling all of the input yourself, you might do it one way. If you're using Dojo or jQuery, you might have some convenient stuff to do there as well. If you're using a game engine, it probably gives you some input handling here to make this easier for you. So things like key presses, mouse clicks, all of that, they should be built into a game engine if you're going to use one. Otherwise, you've got to do this stuff. In this example, I've got a little game object. I'm saying when the game initializes, like the input, when the game is setting up, do a little bit of mapping. This is one way of doing it. Other game engines do it differently. Also, that was just kind of initializing. I want to listen for these keys. Remember, if you remember, I said that every time we cycle through, we want to handle the input. Well, you're probably going to have a function to handle the input based on the state of the keys pressed or the state of the mouse, things like that. Okay, and like I said, all these demos are up. So now I'm just looking at key presses. We're getting a little tiny bit closer to a game now because we're able to take some input and then render things based on that input. I'm just changing the position of where this thing should draw with the keys. Okay. Cool. Okay, so we've got some input handling, we got some drawing, we need some audio. Now audio, with HTML5 we got this audio tag, and that's cool, but that's really mostly for streaming. So like, the web pages you go to, and when the web page loads, it starts playing some annoying music or something. That is cool to do with the audio tag, I guess. But games don't really want to do that. Like, we don't want to set up an audio tag in our game and then like programmatically hit the play button. We want to use a lower level API. The main reason is that by nature, those audio tags, the way they're set up, are very latent because they start streaming, start playing. We want a lower level API to mix sounds, to change the volume on sounds, and for them to just fire immediately. So when your little character in the game shoots his gun, boom, like that should instantly play in that same cycle in the loop. So yeah, we want that. Otherwise, you'll notice if you shoot a gun and then you start streaming from an audio tag later, you'll notice a bit of latency there, and that'll be janky is the word for it just feel really non-responsive. So with this web audio API, this new API, it's part of Chrome right now. Firefox had their own API to do this thing, but they're giving that up, and they are implementing now the same API as Chrome. Maybe one day it'll show up in IE as well. Anyways, this API allows us to, just like we had a drawing context, we're going to have an audio context now. And we could just new one up by saying new WebKit audio context. Now, that right there isn't shimmed like the Requestanimationframe was. Some game engines are shimming this now in hopes that Firefox and the other guys will just automatically start working when their API is done. So in this case, we're doing something specific. WebKit audio context. One day when all the browser prefixes are gone, when it doesn't say WebKit for Chrome, this will eventually just be new audio context. And that's kind of the way all these HTML5 things are working, is that when a new API comes out, it's vendor prefix, and I'm not sure at what point they drop the prefix. It's kind of annoying, all these little Moz, WebKit, IE things in front, but shims, game engines will iron that out for you. Okay, so we got an audio context. Well, how do we get sounds into our audio context? Because when we have an audio tag, we just say its source equals something, and then we say play. Well, with this audio context API, we have to load the sounds in via Ajax. There was some work a while back to set up audio tags and then use the web audio API on top of that. I don't think that's working yet, or maybe it is now. Anyways, it's a lot easier just to grab the audio files that you need with Ajax and then create a sound buffer and a sound source. So um, don't get too hung up on this either. This would be a lot to remember anyways, just from a talk. But basically, what I'm doing in this example is I'm creating a load sound function. We pass in a file name. It pulls it in with Ajax, decodes the data. You probably, waves are pretty safe. I think Chrome will do OGG files as well. I think Firefox will do MP3 or vice versa, of just the codecs that the browser understands. But waves seem to be pretty safe, although waves are big files. Okay, so we loaded that in. What I wanted to do was have just a collection of these sounds, of these buffers. So the buffer is just the data, and then when I have that data, I want to be able to play it. Okay, so I squirreled away these sound buffers in my sound object that I want to play a sound. So here's just a simple function. The only thing I want you to remember here is really that these sound sources, it seems like, well, why don't you just return the sound source and just play that? Because we have our buffer, and then we tell our audio context, give me a source. It's a little convoluted, but you think, okay, well, we created the source, and we're going to do note on, which means play the source. Except that source, for some reason, only works once. So we got to create this source every time from our buffer. So we hold on to our buffers, and then we say, here's a new source. Now play. And we could also do note off to stop one. We could loop these. We could change a lot of stuff in there. So if you want to do any kind of really cool sound effects, you could probably jump really low level into this API and play with all that. Okay. And so using those little functions that I created, we could load some sounds and then play some sounds. Not a big deal. And this demo seems kind of silly, right? We're just going to play sounds, but there's something important in here. Well, the first thing that's important is my kid made these sounds for me. He didn't make the pop sound. He did the other three. But okay, so cool, right? We can play these sounds instantly, and I'm doing this here on button clicks. But what else is important here is that we're able to play them all at once. So, and why that's important is because in a game we're gonna have some music going, we're gonna have a gun shooting over here, something blowing up over there. But we want these things to all go asynchronously so that they all mix together. If we were doing these serially, the game would be really weird. Like, right, you'd wait for a sound effect to finish before the other one starts, all that. But we're able to mix things just automatically because the playing of these sounds is asynchronous. That's all I wanted to show for that. Use it. Some browsers don't support it, but use it today. Use the Web Audio API. Okay, I'm not really going to touch on this other than WebSockets. If you want to do any networking, I'm not going into the details of how this works. If anybody wants to do some Node stuff, this isn't a Node competition, this is a game competition. Nodejs is a server written in JavaScript using Chrome's V8 JavaScript implementation. It's really cool, but there's definitely not a requirement to use this, and this is really just because I have some old slides about this. But if you want to do any networking in your game, you're probably going to want to use Node. JavaScript backend, JavaScript frontend, really easy to message things back and forth really fast. That's all I want to talk about with WebSockets. Although this, WebRTC, I really like, and if you want to use this in a game, like, go for it. This is really cool. It's web real-time communications. Now, does anybody know what Flash does that I haven't mentioned that in HTML5 yet? One thing that people are even still kind of using Flash for is because Flash lets you have access to the microphone, to the video camera, and that's cool, but we can do it just with open standards now. We don't need Flash for that. And what I want to do is I'm going to do a quick little demo here and grab some video, but the way this starts is with another one of these video with another tag. So the video element, like the canvas element, we can just create one of these things. We can give it an ID. We can access it programmatically. So we have this video element, and that's cool, right? So, oops, we can. Wow, I jumped way ahead. We can get access to cameras, but and we can play them in a video tag. We can set the source to some other stream, some other video file, or we can set the source from our camera, and I'll show why I want to do that. But before I jump right into that, the API that we're going to use to do this WebRTC stuff is called get user media. Just like these other new APIs, vendor prefixed, we're going to do some kind of a shim to say, okay, is that get user media function available? Is it available as WebKit get user media? Is it Montes get user media? Is it Microsoft get user media? And you might not even want to use this stuff in your game, whatever. But I just wanted to do a quick demo of some ideas that we could use with the camera that we might want to bring into a game. So we have a video tag because we're going to want to put video in there. But we have to ask for permission to use the camera. The web page has to ask. You don't want, I guess, going to a web page and randomly grabbing your camera and putting a picture of you in the morning on Facebook, I guess. So ask, and to ask, you say, navigator, get user media, and what permissions you want. You might want audio, you might want video. So that was one of the parameters here. And then we're going to get two callbacks, or we're giving it this two callbacks. One is, if everything is successful, yay, we have access to the camera. If not, I don't know, you want to do something else. Log an error, go away, whatever. Okay, like I said, the reason I started with a video tag is that I want to get access to the camera and put it in that video tag. That's exactly what I'm doing here. So programmatically, give me that video tag, and then set its source to a local stream that I created from get user media. You don't have to remember all this, but what that does for you, of course, is allow you to. So here's the how it asks. When you ask for user media, it pops that little guy up right there, and so I'm taking the camera and putting in that video tag. That's all that's doing there. Close a couple of these up here. Okay, so that's cool, right? But we want to not just have a video stream. We want to take some data from that, right? So how do we do that? This is kind of strange, okay? And I wouldn't say this API bothers me, but it's a little weird. We have a canvas that we were able to draw images into. Canvases are weird. Once you have that 2D context and you say draw an image, it doesn't have to be just an image. It could be a video tag. So you could take that video and put it into your canvas. You could put another canvas into your canvas. So draw image is actually pretty powerful. It takes images or videos or canvas, or I don't know what else it takes, but it does that. So all right. So again, allow. And this first button, all I'm going to do here is I'm taking, like I said, I just used that example. I took the video and I put it into a canvas. Oh, I'm sticking my tongue out. That's awesome. All right. So you notice I can't right-click and save this picture as because it's still just a canvas, right? In Canvas, we don't save the image. However, we can still get to this data. We want to have like an image that we can play with later, right? We don't want to just have this canvas. Let's do an image. So Canvas has got a really cool thing built into it that lets us get the data as base 64 encoded data. That just means it's a string instead of just binary. It'd be a big image file because base 64 text is bigger than binary files. So anyways, we get this image data, and then we can set an image source to the image data. And what we could do with that is finally, okay, allow. And if we click again, now finally, see save image as, because now we have that video frame finally into an image, which we might want to do other things with. Okay. Like, what would we want to do with that? Well, maybe we want to, for a game, or for whatever reason, if we have some image data, maybe we want to do stuff with the individual pixels in the data. Because what is a bitmap? It's just a big two-dimensional array of colored pixels. Well, we have a way now to get each one of those values using HTML5. So any image that we put into a canvas, we can then get all the image data from that canvas. So this one's really bad. Shayla really likes this demo. It's more boxes, yay! Okay, so boxes, yay! So that did everything that I said before, and then it took the image data and we put it into a real simple game engine here, applied some physics, just one dumb thing to do with the tech. All right. Can you use this one as well? If you're targeting Chrome, yes. This slide is a little bit, I think Firefox is a lot closer now. Anyways, use it. All right. So we did 2D context. We did some input, we did some video. You may want to do 3D. It's a lot harder than doing 2D, right? And when I said we have access to a 3D context instead of just a 2D context with our canvas, we can, if we ask for 3D, it's Webgl, which is basically an JavaScript implementation of the OpenGL ES 2.0 spec. What the hell does that mean, right? It's just hardware acceleration. It defers calls to your GPU, so you can do fast 3D rendering in a browser with an open standards. And it's like really easy to use, right? You just read the spec and go through everything, and totally tells you how to use it, right? Like no problem. Or you could use something a lot easier, like 3JS, which is another API. It isn't a full game engine, but it does a lot of abstraction of that crazy spec of OpenGL. And all we have to do with this is just use these APIs to set up a scene, set up a renderer. A scene is like our world. The renderer is what's going to draw it for us. A camera that says where to draw this thing at, and then throw a bunch of objects in there and get it going. I'm not even going to go through this. Just real quick. Okay, set up a renderer, camera, all these things that I said. And what do we get as a result? Here I'm setting up a scene, loading a texture, building a mesh, and what does that give us? Yay, crates, right? That's what all first-person shooters are built on. That's most of Half-Life 1 right there is a crate. Okay, so good. We got a 3D object. We're moving it around. We're rendering it. We did some texture mapping on it. All that stuff. If you want to use WebGL, I'd recommend going for 3JS for that sort of thing. And it isn't just crates. I mean, you can, you can do really creepy stuff like that. So this is a very complex mesh. It is a pretty high resolution texture. It's doing the dynamic lighting, bump mapping, all these like really advanced 3D things. We're able to do in the browser, and the performance on it's fine. And so if you want to use that, I mean, you could build some. I mean, it's not PlayStation 4 yet, but it's there are some pretty cool things you could do using 3D tech in the browser right now. Okay. Also, we might want to gamify somehow, maybe mixing some of these technologies, right? Like, for example, I said we can get pixel data eventually from WebRTC. We've got WebGL to render stuff. I didn't write this. This is a really cool demo that I didn't write. And this totally isn't a game, right? But it's some weird toy anyways. That's reading WebRTC data, rendering with WebGL. So, okay. Yeah, and totally use this if you want to do 3D. Don't worry about who supports what. How much time do we got here? Running a little bit late. Okay, so can we run all this stuff on our tablets? Right? Yeah, it's great. Everything works perfectly, right? Like no problems at all. Just render the stuff right on. Just fire it in. Everything's perfect. Yeah, not exactly. Not even close. They're in various states. Like the one for iOS, iOS 6, and especially the newer tablets, the newer iPads, they have web audio. Now iOS 6 is web audio, which is cool. It's got a fast canvas, and you could use WebGL for iAds. Not for your game. I don't know. It's weird. Android, if it's less than 4.0, the browser in there is Android browser, and that's horrible. That's the new IE6. Like that's that provides us a canvas, I think, and that's pretty much it. The Chrome that's on the newer Androids, on Android 4, is better, but it's still missing a bunch of things. I've got a bunch of issues that I'm following on the bug tracker for Chrome for Android, and they're all marked as, the ones that I want fixed are marked as release 24, I think. So I don't know, but I think 24 should be pretty cool. We're on 23 stable right now. However, Chrome on the Nexus 7 on the latest Android is still at 18. So if they bump up to 24 when the rest goes up to 24, yay, we get all this stuff. But I don't know when that's going to happen. Firefox is cool because on Android it's got WebGL and it's decent. There's another browser called Bowser on Android. It's got WebRTC. BlackBerry 10 looks pretty good. It's got WebGL. So it's got a few things going on. I don't know anything about IE10 on Windows 8, other than IE9 had a pretty good canvas. That's really the only really good thing I could say about it was that it had a fast canvas. So I imagine there's other cool stuff in IE10 for game-related purposes. Okay, all right. So mobile, yeah, you're going to build something really cool maybe, and it's going to run like crap on the phone or on your phone if it works at all. But it's getting better. There's a couple other topics. I'm not going to go into any detail at all. Just things that you might want to look at in your game is we've got web workers, sort of like threads. We can defer a lot of processing over. JavaScript is single-threaded, but web workers allow us to defer some processing. Device orientation. If you do put something that has on a device that has an accelerometer, we've got an API to tell us if like your iPad's tilted or whatever. There's APIs so automatically things go to full screen if you want your game in full screen. Mouse lock API. You don't need a first-person shooter. You move the mouse around, the whole screen moves, but you don't see the mouse cursor. It's mouse lock. That API is available in Chrome. There's a gamepad API if you want to plug in a controller. Okay. Also, if you want to eventually take your game and make any money on it, is it possible to make money on HTML5 gaming? Well, there's app stores, right? So we can wrap this stuff up, put it in an app store like the Chrome Web Store, Firefox, Marketplace, all these things. Maybe charge for it, so you could make money that way. You could get funded by a venture capitalist, I guess. Some of these guys have made a lot of money. My favorite card game is called Dominion. This guy is called Goko. They got $8 million to build that and some other games. So cool. I don't know how much money's coming in, but it's being funded. Although one of them got a lot of funding and they're already done. I didn't come up with all these numbers. I stole this slide from Pascal Redding, really cool HTML5 developer. Okay, I got some other links here. Okay, so that's high-level overview of some APIs that we can use today. Before I would like to also go through at least one game engine here, just real quickly, a couple of demos. If you well, after you form teams, you'll have a better feel of, I'm sure, if you're going to just grab a game engine, try to go with it. If you're going to write a lot of things from scratch, just using like Canvas APIs and things like that, however you want to do it. But I want to take you through some real simple ways to use a game engine. Before I do that, does anybody have any questions about any of these HTML5 APIs? Anything? Nothing at all? Sorry, I went through them kind of fast, but I didn't want to spend too much time on the real details other than let you know there, because we're going to be walking around helping anybody as we hack today. Oh yeah, I already gave it. Yeah, well, of course, I'm going to pimp my game engine, right? But it's, don't have to use it, but it's really simple. And Lime.js, Melon.js, Creative.js, there are other game engines that all pretty much do the same thing. I like mine and I can help with mine, but okay, so mine is, and Blaine's is up here at icedev/frozen. Very, very simple game engine. Could be, you could just jump in and start using just the animation loop if you want, or you could, do some more advanced things with it. But just that loop structure at the core, you probably, you could write that if you want, or you could just grab one of these and start going. And let me show you how to I'm just going to run through a couple really quick demos to show you how to jump in and use this one in particular. Sure. I do actually. I've got mostly demos. This is actually playable, although this is using a much earlier version of the game engine. It's a lot more efficient than this. This is on the Chrome Web Store. This is over a year old, and my graphics were horrible. But this was, I guess, the first one that was a complete game that I pushed up. We've got a lot of other things in the works and a lot of like tech demos and stuff like that. But this was a fully playable game using an older version of the engine. Sorry, let me. Okay, cool. Sorry, I am just firing up a little server to run my examples. Okay, so Blaine really hates this logo, by the way. So I had to put it on here. That's not our official, I guess, but it's frozen and it's JS. Yay! All right. Okay, so yay animation. So that whole loop thing. Let's actually, what I'm going to do is I'm going to bring the source up in Sublime, because Sublime looks a lot better. And wow, I got too many files open. Is it washed out? Oh, that's because I need to view. Which one is it? There's a really good one for projectors. Sorry, color scheme. How's that better? That's not better? That's the one I'm supposed to use. Okay, all right. Let's see here, preferences. I'll zoom in too, just a sec. Color scheme. I don't know, any suggestions? Something white. iPlastic. Better? Okay. All right, let me zoom in. Well, first I'm gonna go to my examples here. Okay, so animation is the example I want to go to. Let me view. Where's zoom? I guess just Control plus. Okay. All we're doing here is bringing in a library. It's frozen. You can bring in Creative or one of the other ones if you want, but and we're setting up a canvas. This is using the AMD spec, which means it's the JavaScript is written in little modules. We can aggregate those modules. We can do AMD is really cool. Way out of scope for this talk, but since it's using AMD, you can organize your code. And in this case, all I'm doing is requiring in just my little game core here. Like I said, part of our loop is that we want to run updates and draw things. Well, that's all this is doing. So I have a little game core object. I have an update function, and I'm not even really paying attention to the time. This is a really simple example. All I'm doing is incrementing an x and y, and then I'm drawing it. I'm drawing a little square. And so just for animation, we have an update and a draw, and that's all that did, and just drew the box across. Okay, that is the absolute most basic thing that we could do. Input. So if we want to move something around, we need some type of an input manager. And so this is a little bit more of an example. When my game initializes, I can tell it map some keys, map the arrows. Every cycle, when I want to handle the input, I could say, okay, that same thing that I just did with the x's and y's of incrementing. Well, why not increment or decrement based on whether or not a key is pressed, and then draw it. There isn't really a game state here. The only game state is what that x and y is. So my update isn't really doing anything. My update function, all I'm doing is just on input, changing that value, and then we're drawing it, and that's all that is. Okay, so that's input, that's animation. Those are the two concepts I already brought up before. Same with images, and oh yeah, okay, now we're getting a little bit more of a stupid game. We have a background image and we have a little character. So in this example, which is the image example, Same thing as before. I want to do a little bit of input management, but what I added was a resource manager so that I can load the images up, and the game won't start until the images are loaded. So that way, that allows us to do a couple things, right? We can add a whole bunch of resources to the game, a whole bunch of images, sounds, and all that. And you need a progress bar, things loading. I mean, this is all basic stuff that's been around in Flash for a while, but we need to do it here as well. We need to monitor when these things are done so that we can use them. Otherwise, if you try to just load images and start writing them to the canvas, you're not going to get anything until the image is completely done. It isn't like trickle down on a slow connection. It's like that image isn't ready. You try to draw it to canvas, you get nothing. So we needed a resource manager. That's what we did here. In my draw, I drew the images that I had loaded with the resource manager. Okay, and let's see, a little bit more here. Just a couple more examples of this. Okay, so the same thing. I just added that same sound effect. So and to do that, it's the same as the resource manager. So this just builds on the last example. Very, very simple. I added a sound using that same resource manager. Created a sound, and when I hit the space bar, I'm playing the sound. Pretty straightforward. All right. Okay. Now, just moving the stuff around on the screen is fine. Like that's some animation, right? By just moving things around. But games don't just do that. They don't just have something statically moving. They also each character or each sprite on the screen, not only does it like change position, it might have its own animation, or wait animation. Maybe it's standing there, it's looking at the clock because you're not moving the character around, or when it jumps, it throws its hands up, or anything like that. So what we need is not only where the position of our characters are, but sort of what state in their animation they are. And we want that to be fluid. So if your computer slows down and each one of these intervals is more than 60 milliseconds because you're only getting a few frames a second, we don't want it to speed up or slow down the animation. It might get a little jerky if your computer isn't fast enough or your code's really bad. It'll get jerky, but at least it won't. The animation of any one of these sprites won't be dependent on that. So okay, so what this does here is this is a really bad image that I took from a site that basically had had a bunch of positions for this character. So if it takes him 2 seconds, like I said, to go through a full walking animation, even if I'm getting 1 frame per second, it'll be completed in 2 frames. Does this concept make sense to everyone here? That we're using a library to keep our animation consistent. Because if we're on the super fast computer, you don't want the character to just start wigging out, and rendering really fast. You want that animation to know which frame that we're on. And let's see here. So some simple APIs just to create an animation from a tile set. Also, an important thing is when you make a sprite or something, an animation with a lot of frames. Maybe it's just 8 frames. The guy's changing position in the image. You don't want to load each one of those images individually. You want to aggregate them into one long image, and then render which section of that image, depending on where you're at in that thing's timeline. And so this does that. I won't even get any more into the code than that, other than it's available to build these types of animations. And one last thing is the famous Box 2D, what Angry Birds was built on, right? And sorry, that is right here. Okay. So we can put shapes in our world. We can crunch some numbers using Box 2D. Box 2D is a 2D physics engine. It's pretty helpful for these types of just 2D games. It'll do our collision detection. It'll do gravity for us. Each one of these objects could have a density. They could have an amount of bounciness, how much friction they have when they slide across the floor, all of that stuff. But Box 2D is just crunching the numbers. It's not rendering anything for us. So we need to create a bunch of objects, give them to Box 2D, tell it to do the math, give us back the results, and then we render things. So in this case, I'm using input to just apply a force to the little cat here and interact with things. Now, these other shapes are like this pyramid is polygons. The moon here is a circle. But those shapes I'm not rendering. I just have a background image, and then I set up the shapes in my code and gave them to Box2D. So Box2D knows there's a pyramid here, but it's just the background image. Same with this circle here. This is actually another image that I'm painting on. But like I said, Box2D, I give it, hey, here's a circle. It comes back with, okay, the circle is in this position, it's at this rotation, and I just handle that in my drawing. Let me show you just real quick the code here, and then we can get started hacking. What's that? Oh, yeah, okay, so every time we paint to the screen, if we don't sort of clean up after ourselves, we'll have artifacts, right? Like if I just started painting that little ball of yarn to the screen and didn't clean it up, I would have, I would just have a long streak of that yarn ball. So I could clear the canvas out, or in this case, all I'm doing is just painting a background image over and over and then putting the things on top of it. So that way it clears whatever is behind it. That may or may not be the most efficient way of doing it, depending on what you're doing, because you might also have a huge scene. This was just a little world here that I'm bouncing around in, but maybe your world is immense and you're just rendering a little portion at a time. You don't want to paint the whole thing. So there's going to be a lot of performance tweaks, things like that you can do, but at least you want to clear out the areas underneath where you have things moving, so that you don't have little artifacts each frame. Okay, this example is a little more complicated, but all I'm doing, what looks complicated is there's a lot of code, but I'm just creating each one of these shapes. I'm creating a box using my engine and just adding some things to it. Also, I'm keeping a reference to those things that I'm adding just for efficiency, but if anybody wants to see any of this code or has any questions, like I said, we're all here all day.
So we're really bad at documentation, but this code is very copy pastable, and it's in the examples folders on the project.
So if all you wanted to use was just the game loop, just grab that animation and start going. You don't have to, but if you wanted to, we can help you with that. Just grab a really simple example and start going by editing what's happening in your update, editing how you're handling input, change your draw up, and you've already you should be able to start cycling there on development as soon as you have that little bit of backbone ready. I guess that's it. Any questions about any of the stuff or anything about the competition? Do you already have well, Blaine's going to explain all this. Okay, good. Okay. All right, well, if you got any questions about any of it, come hit us up. All right, so thank you.